Hello, everyone, and welcome back to Outspoken Market Global. Leandro Guerra is speaking, and in today's class, I want to share with you the results and the outcomes from this beautiful paper from three Google researchers entitled Prompt Repetition Improves Non-Reasoning Large Language Models. And this is exactly when we say that, look, instead of you placing your prompt once, you do it twice in the same chat, in the same window. You simply make prompt and then repeat just after the thing that you wrote. That very simple trick increases or improves the performance in a dramatic way for non-reasoning tasks. And we are going to see why that is the case in a few minutes. And another important message from the paper is without it does that, the increase or the improvement into the performance without increasing the lengths of the outputs or the latency, which is a matter of essence, especially for online systems. And that works not just for a model, a single one, because it eventually could be just a coincidence. No, the famous ones, Gemini, GPT, Claude, DeepSeek, all of them, they got improvement into the outputs after performing this very simple task. And here, for example, it's what we could call the free lunch anomaly, because in a task of name index retrieval, for example, Gemini 2.0 flashlight without any particular fine tune, no changes in the architecture, usually with a single query would give an accuracy of about 21%. With the repetition strategy, so query plus query or prompt plus prompt, it got as high as 97%. It's simply amazing. And then in the paper we can see also the other results from the other models as well. And I think the point is, okay, Leandro, why does it happen? What is the reason behind that? Why do we have such improvement with a very simple stuff? The root problem is what we could call causal blindness. A large language model, and please, I mean, take seriously what I'm gonna say. Large language models, or the so-called AI, they are not reasoning beings, they're not beings. They are mathematical models. Mathematical models are pruned or they are open to mistakes, to errors, like any model. The models are not perfect. Okay, so a large language model, as the name suggests, it's a model. So it does not reason, it does not think, it does not take any action in autonomy unless explicitly programmed for. And if there are any problems with the actions a large language model took, mainly also into an AI agent problem, it was because there were no constraints by the user or the programmer behind it. That being said, the root problem is, as humans, or at least the majority of the languages, because we know that there are some languages that they go from right to the left, but they read linearly from left to right. So when the model it's processing the start of a prompt, assuming the single prompt, the model is blind to the feature because it starts seeing from here. And then by doing the repetition of the prompt, you kind of reinforce that particular view. Just like humans, although I don't like this kind of anthropomorphic comparisons because they are mathematical models, we are humans, we are different, we are superior, and all the rest. But just like as we do when, for example, there is a complex sentence or a complex paragraph that eventually, if we read it twice, it changes our perception, our understanding. A similar stuff happens with the model. So that is the point of rereading, or what we could even call the pseudo bidirectional attention. So again, reinforcing whenever you repeat the input, so P becomes P for prompt, that second interaction would be like the privileged reader attending to every token of the first interaction simultaneously. And this is what makes so beautifully simple and efficiency gain is observed. I mean, it's quite interesting that honestly, if you ask my opinion, I think there are many other things yet to be discovered on how we can gain efficiency in the utilization of these language models without necessarily changing any architecture nor anything else. And like any kind of technology, remember the first big plasmas TVs, and then we got the LCDs TVs. They were large, they were, I mean, heavy. Now they are also large, but in the way that we want to. And they were expensive. Now they are really thin, they have better resolution, and they are way cheaper. In my view, the same thing is gonna happen with this technology. And then it's quite interesting because here is, for example, many of the models they got approximately the same type of performance, and then on that particular task of name index, all of them, Claude, Gemini, DPT, and although there are some specific versions being quoted here, I did myself the test once I read that article using the more advanced GPT versions like the 5.2 or the 5.3 and for the codex, and indeed I noticed an improvement into the results. So it's really, it goes beyond just the versions quoted in the paper. And another important thing for the ones that they deal with online systems, we have what we can call the latency paradox. So twice the input, it's very different of two times the latency. We will not have. It's essentially the same, right? So that idea, so you should not be worried about that. So the idea, right, that you would have a a higher latency is not the case. So you have what we call the prefill that eventually grows with input, but then the decode, it's serial, it's slow, it's kind of content. So and that is the point of the total time. So you see the total latency, it's marginal. There might be, and here I know that there will be the exceptions. Eventually some systems they would be sensible for this type of latency, yes, but it's not that we got 1 second and then we go for 2 seconds because we are repeating the prompt. That is the case, right? And then where it fails, well, I told you in the beginning that it fails when we have the reasoning, because when doing reasoning we don't uh, fall into the same need of repeating that. That being so, why eventually we have that, and why thinking models don't need it? The idea of what we call a reasoning model, for example, it's something called the chain of thought, that it's already internally a repetition. Not sure if you notice, if you use the reasoning function, you will see that the model, it's kind of showing the steps that it's running. And eventually it gets, oh, the user has asked for this. And what the user asked was, and then it repeats several times the task or part of the tasks that you asked in the prompt. So that chain of thought it's already doing the repetition. So that is why it was not observed any gains when doing the prompt repetition in that particular case. Now, interesting. I couldn't get, and I'm not sure from where they got that idea. So if eventually already observing the how the chain of thought works, for example, that they got the idea, okay, what happens if we do this before using the reasoning? I mean, from where the research is, they took that particular idea. So I would be interested, quite curiosity, only to understand from where it came from. But nevertheless, it's not less brilliant, rather the opposite. Even if they look at inside and they got the idea, okay, let's put that outside, it's yet brilliant. So to close, we have what we can call the engineering decision matrix. So what is your task type? It's about retrieval, extraction, formatting, repeat the prompt. So for JSON outputs, contract analysis, for example, or RAG systems, repeat the prompt. It's a nice practice that we can observe here. Of course, if you observe any anomaly related to your system in particular, it's not that you will be forced to follow that. We are just suggesting that, well, look, that is something, right? If there is uncertainty, well, repeat it. If it does not hurt, you can keep using. If it hurts, then you do other strategy, you try to do something else. If you go for mathematical approaches, creative approaches, or complex reasoning from the models like novel writing and etc. So you keep using the complex reasoning, you do your standard prompting or other prompting techniques that are not related to the repetition. And and the point about this, it's previous prompt engineering suggestions. They were related to many things. Oh, be nice to the model, put in a JSON format, establish the actors, and etc. So all of them, they have their pros and cons. And here, for example, we are not just asking nicely, we are working the structure of the prompt on manipulating also how the model attends to information, how it reads the information, and of course, maybe future versions we already take this into account. So you are not the one that will have to write twice. The system that you'll be using will take your input, will double that for you, and then activate the whole point. Okay, so thank you very much, guys. If you want to know more or have any particular questions or doubts, just leave here in the comment. Subscribe to the channel and see you next time. Take care. Bye bye.